Hello, Master Tron Tamer here. I've got another project for us, another soldering project. I had so many people interested in the Learn to Solder one that I did earlier that I thought we'd do another one because practice makes perfect. So I've got another kit for us here to take a look at. So this one is all in this one little bag. Let me go ahead, put on my reading glasses so I can see what's in our bag. Okay, so what we've got here is a wheel of moving lights that we're going to work on, and we're going to put that together. We have a battery holder and the various parts that we need. So it looks like we have what we're after. And this may be our instructions. So not a lot going on there. Here, let me turn that the right way to the camera. So this shows us where the parts go. It gives us the layout there. Yeah, and it looks like it's the same thing on the back, unless I'm missing something. So this would be a little more difficult for somebody who was doing their first soldering project than what I showed you before. But let's go ahead and do this one, and we'll kind of work on it together so that we can understand it better. So let's start with the chips. Now this kit gives us sockets, so we'll be soldering those in. And that looks like a 555. Yep. It's an NE 555. And then this one is a CD 4017. So if you wanted to look that up in a reference, feel free, but that's a decade counter. In other words, there are 10 outputs on it and they go in sequence. So I'm assuming that this 555 is going to be set up to send the timing circuit, and then it's just, this will step through its 10 outputs to give us the lights that go around. I'll put a link to some references for that chip so that if you want to look that up, you can. And you can see I've already got my silicone mat set out here. So this is really nice, as you can see. I'll put a link into where you can get one of those too. But I'm not going to lose any parts. That's the big plus with this situation. All right, so let's go ahead and get started on this. So usually in a case like this, we put resistors in first. Again, we don't have any real instructions, but let's go ahead and do that. So what resistors do we have? We're supposed to have a 10K and two 470K and then one 470. So I will need my glass to look at these so that we can see what we've got. All right, so we've got, that doesn't match. Let's look at the next one here and see. Okay, now that one makes a little more sense. That's yellow, purple, black. And these two are on the same thing. So those have got to be, yeah, yellow, purple, yellow as well. And that means that this one is the 10K. Yeah, brown, black. So In a case like this is one of the things I wanted to show you. If you're not 100% sure, just put them on a meter and find out. That's the easiest thing to do. So let's go ahead and we'll put our meter on resistance. And see what this one measures. Okay, so that's 466 ohms. So that's within the tolerance for our 460. And then this one is within tolerance for the 10K. And that means that these ones, are 458, 460K. So that puts them in tolerance for those ones. So that's great. That gives us basically everything we need. I'm going to put them in their thing so that I don't get them mixed up. Move this out of the way. Okay, let's go ahead and start putting this together. So let's use our little diagram to see where that 10K goes, and we'll put it on first. It goes right in the middle of this circuit board right there. They've stenciled 10K. So let's go ahead and put that one in. I think what we'll do is we'll solder all of these together at the same time. Alright, so there's the 10K. And then the next thing we have is the 470K. That's the ones that are on the same together. And this last one is the 470 ohm. I'm thinking that that is the current limiting resistor for the LEDs. They didn't give us a schematic, but that would be my guess. Because of the way they're configured, only one is on at a time, so we only need one current limiting resistor. Alright, now we can just go ahead. I'll put a little light on here to make this work better. And we'll start putting those in. So to solder these, and I mentioned this in the other videos, I'm going to put my tip just on the other side of the wire in the pad, and I'm trying to connect to both, and I come at it from the other side with just a little drop of solder, give it a quick count, and then go ahead and release it. And we'll keep doing that. We'll it'll work better if I keep my tip clean. So again, this will probably give you a pretty good view on this one because it's not as crowded. Coming at it from this direction, solder from the other side. Hold it for a few seconds. Pull off the iron. Alright, that takes care of those. And I see, of all the things I pre-positioned to have ready for this, I don't have my clippers. Oh, but I also notice I have a problem. Let me put some light on it so you can see it. One of my resistors fell out of its position and got soldered wonky. Now, to be honest, that might work, but that's just kind of shoddy work. So what we're going to do to fix that is bend it up so that it's ready to go back in, and then we're going to gently heat it while I'm pushing it in with my finger. And we'll have to do this on both sides. Alright, it's all the way down on the board now. So that's one of the reasons we inspect them. I'll go ahead and just put a little solder on that. And let me get the other one. Alright, that's got them all on there and they all look good. Well, I'm going to go run those nippers, get those nippers, and I'll be right back. There's always something you forget. Let me grab those. Okay, I'm back. I've mentioned this in other videos, but I just want to hit it one more time. There's a reason that we wear some type of a good safety glass. This is one of the more dangerous times because these things can go flying. We try to be careful with them so they don't, but sometimes they do. We definitely don't want to get one in our eye. Okay, then it's always a good step to go ahead and visually inspect them. They look good to me, except one looked like it could use just a little bit more solder. Doesn't hurt. So now we've got them all, and like I mentioned before, we're cutting them about a millimeter and a half up from the board. We're not trying to actually cut into the solder itself. We want that to mechanically hold that together. Alright, let me move these out of the way. So now that we've got the resistors in, quite often the next thing that we want to put in is the sockets. In this case, they have given us sockets for both. And the sockets have a notch in them, which is going to match a notch which is on the chip. So both of these have a notch right here. So we want to orient those because so does our circuit board. We can see the stencil marks have also got those notches. So we want to make sure we get our sockets lined up with those. So that one's gone in good. And now the one for the timer. Okay, so I don't know if you can see this, but this one pin was just bent in just a little bit, and that's why it wouldn't go in. So never force things. Kind of look at it, see if you can figure out what's going on when something won't go. There we go. And we even kind of look on the other side once we've done this to make sure we have all our pins and everything looks straight. All right. Now it's time to solder in the socket. And I'm going diagonally and putting in the corners, and that's going to hold the whole thing down like it should be. And now I can go ahead and just put the rest in. Seeing how we don't have a chip on there yet, we don't have the same heat worries that we would have otherwise. We could melt the socket if we took too long, but we should be okay. So again, iron from one side. I'm touching both the pad and the pin, coming at it from the other side. Give it a couple of seconds and pull it off. I'm cleaning this like I should. There we go. Oh, that's much better. I'm going to reheat that one just a little to make sure I've got that one good. Oh, that's my meter telling me to turn it off. I'll go ahead and do that. We're going to need it later, but not for right now. All right. Now we'll do the timer. Let me go ahead and turn that off because I think it'll beep again. All right. And this tip has a kind of flat side to it. That's one of the things I keep looking at. I'm laying that flat side right on the pin so that I get good heat transfer. All right, and we'll look at them. Yep, they all look good. All right, so what do we have next on our little diagram that we need to get put in? I say we put in the switch next. So that goes right in the middle of our board. And I don't know how well you can see this, but the holes are kind of not in a square shape for these little tactile switches. They're in a rectangular shape. And we have to get them the right way. In this case, it would not fit like that. That wouldn't go in. But it does go in pretty well this way. Now we're going to be pushing on that switch, so we want to make sure we've got it on there good. Alright, so now we've got the switch. Quick check on it. Looks good. Alright, so what else have we got to do? Resistors, capacitors probably come next. So we have this little tiny, it says it's a 103. That's a little despiking capacitor. The board is stenciled for 103. So we know where it goes. So this one's going to want to drop out of there when I go to solder it. So that one's a little trickier. So let me show you how I'm going to do that. I'm going to put just the smallest amount of solder on it and then push it with my finger from the other side. And that looks good. I'll solder the other lead. And then I'll go back and just hit that last one more time because I want to be sure. Alright, we've got that little 103 despiking capacitor in there. And we've got a couple more. So what we've got here, it says we've got a 47 microfarad and we have a 10 microfarad. So this one is marked 47. It's a little hard to see, but it is marked 47. And then there's a band here where it goes, it says that this is the negative lead. The negative lead is also shorter. So we'll look at our circuit. And for the 47, they show which one is positive. And like I said, there's a big stripe that says negative on one side, so that one goes in the other way. Alright, then we want the 10 microfarad. Okay, this one is marked 10 microfarad. It also has a stripe with a negative sign, which goes opposite the little plus sign on the board. And then what else have we got? Got this SW200. I'm going to have to look that one up. I am not 100% sure what it is. I'm thinking perhaps it's a choke. I see no polarity markings or on the board. So It should be able to go in either way. And we'll put that in. And that takes care of everything except one transistor, and we'll come back for that. As you can probably see, I am pushing it up from behind again. Just making sure I've got it all the way. Now to get it to move, I actually had the iron on both pads for a second. And that was deliberate so it would move, but you gotta be careful you don't end up with a solder bridge. And I'll be inspecting for that, just to be sure. And that looks good. Yeah, well, I think this one was going to stay up there very well, but I'll figure that one out. We're going to do the same trick where we put just a little bit of solder on it and then push it up. And one side will hold it nice and firm while we solder the other. All right, those all look good. So we'll trim those. All right, that leaves the transistor, which I'm assuming, yeah, it's a 9014. The stencil shows a flat side for it. So we're going to go by that as far as the alignment. Now with the transistor, depends on the application, but quite often they dissipate a little bit of heat. So having a small amount of lead underneath it sticking out is not a bad thing because that actually works as a heat sink. So that's the way I'm going to solder that one in, a few millimeters above the board. Okay, that's the majority of the work. I'm looking for solder bridges. I don't see any, and everything's nice and shiny. So we're just about done. The next thing is to mount the LEDs in, and they don't tell us particularly which one goes where, and I'm not sure it makes any difference. So what I'm going to use is this color chart from the color picture and put them in that order. Like I said, I don't think it makes a lot of difference. So with LEDs, one lead is longer, and that is the positive. And if we look on the flip side of the board, we see that one is more square and one is round. That is the positive, is the square one. The other way we could verify that is with the meter. So I wanted to show you that. We'll put it on diode test. Let's see. There it is. So that's diode test. What's cool about that on a meter is that we can use that. Here, I'm going to put this light up a little higher so you can see that better. Is when we put the probes on it, we should see it actually light up when we've got it going the right way. Yeah, it's not bright, but it's lighting. And if you'll notice, my probe is on the longer lead for the positive. So that's how it should be, flowing from positive to negative. So the long lead, again, we verified it as positive, and from looking at our board, that's the inside pad. You can also see the diode diagram stenciled on the board, and that tells us from our test that it is going this way as well. Long lead towards the middle. And these are going to have to stand up a little bit, it looks like, and that's not an issue. The holes, if they were a little bigger, we could flush. Oh, it still goes in there, so it's okay. All right, so I'm going to go ahead and put these in. Long lead. Oh, this is going to beep at us again, so let me move that out of the way. Yeah, I think these will be more stable to sit right on the board. We'll do the same thing with the red. Well, they're not going to fall out because of that. And then they have blue. Long lead for blue. And green. And yellow. Long one in the middle again. Then we start all over again with the clear one. That means red's going to be next. Another thing is that sometimes there's a flat side on the LED, and they have designated that on the board. These particular ones don't appear to have a flat side, not that I can see. But that's fine. The leads are telling us everything we need to know. All right. Green. And yellow. So I'm going to flip it, and what I'm doing is verifying that the longer lead is always on the inside, on the squarish hole. All right. And then we're just going to solder them. Now they are a little heat sensitive, so we need to be a little wary, but not, overly so. But I think because of that, I'm going to go around and do one of them at a time, and I'll come back and do the other lead. Not quite enough. There we go. Now that I've gone all the way around, I'm going to lift it up and inspect that they're all straight and that they're all flush on the board. And they look good. So now I'll go ahead and solder the inside ones. And again, that's giving it a little time for it to cool between goes. And that's a good thing. And then of course a quick inspection. They all look good. Okay, double checking, didn't cut too close. Yeah, every now and then you see when you just want to touch it just a little bit. And I cut that one a little close, and that's why I put a little more heat on it. All right. Well, that is complete, except for the putting of the chips in the sockets. But while we're at this, another thing I wanted to do was talk about how we could power this circuit. It says 3 to 5 volts, and they've given us this nice little battery holder, which holds 2 AA's, so that would be 3 volts. We could power it that way. There's nothing wrong with doing it that way, but I wanted to show you another route. And I'll put links both for this kit and for this. So this is a kit which has got some USB cords with what we call a pigtail on the end. And I'm going to use those. The advantage is, a lot of noise, the advantage is I won't need a battery, because I can just plug this into any USB charger or laptop, computer, or whatever to power this now. And that's going to be better than having to go out and get batteries. This particular kit came with some little terminal blocks too, which is cool. I think what they had envisioned that you were using these to repair a broken power lead. But that's a nice add-on. Of course, we know how to solder, so if we were going to be repairing a broken lead, we'd solder it. And that's what I think I'll do in an upcoming video. I have mentioned this in some of my others about good ways to put things together with 2 wires, but I want to actually demonstrate that a couple of more times for you so you can see that. But before we get there, let's figure out what we're going to do with this. Well, the first thing I'm going to do is separate these leads a little bit for the next step. Bring back the meter and put it on voltage. Then over here to my left, I have got a power strip with a USB on it. I will plug that in momentarily. And then taking my leads, and this is another important step if you don't want to mess this up. Look at your leads and make sure you've got them plugged into the right place. The black one goes in the one said COM. We're measuring voltage, so we want the red one right here. If we were measuring milliamps or amperage, we would want it over there. And then we're going to put the black one on the black and the red one on the red and measure it, and it comes up 5.1 volts. Perfect. That's what we want, and we verified that this is the red terminal. Now, you might think that that's silly because red is always positive, but not always. You need to be careful about these things. So, for instance, in recreational vehicle wiring, white is negative. So you can have all kinds of different combinations in a cord. So you definitely want to verify it. And this is particularly true if you've gotten a hold of a used cord, which would be another way to do this. And it's got 4 wires coming out of it because it's an actual serial cable. Then you do need to identify which one is the positive and the negative, and the surefire way to do that is with your meter. So now that we've verified it, we can go ahead and solder it in, because it is marked which is positive and which is negative on the board. Well, they have put a teeny tiny hole on there, which, just to be sure, fits the battery wire pretty good, although we would need to strip a little more off. But it's not fitting what I want to do very good. So even though these are pre-tinned, which is a big plus that they've gone to that extra work, we need to nip it down a little bit so that we can get it in the hole. And let's see if without the solder, if it'll go in there okay. I think it's still going to be a little bit tight. So if we had a very small drill bit, which I have but not handy, we could enlarge that hole just a little, and that probably would not hurt a thing. The other thing that we can do in this situation, seeing how we're not really worried about how much current this is going to carry, is now nip off about 1/3 of the wires, which is going to make it a lot smaller and probably go through the hole much better. This is actually a really nice cable. It's got a nice gauge here. It could carry, I'm sure, at least an amp, which is what most USB is rated for. So yeah, I'll keep these in mind for other projects. Alright, now let's see if we can get it in the hole. Yep, now it goes in there just fine. I would normally do these at the same time, but because of this unique circumstance, I'm going to go ahead and do them one at a time. And I'm going to be touching that up, if you're wondering why I went so fast. I just want that one to hold in while I put in the other one. All right. And I think I need to take a little bit more off of this one before it'll go in there. So I'm going to do that. And I'm giving it a little twist, which will help it. No, I guess that one is just a little bit smaller, so I need to take a little bit more wire off. Bring the light down here a little bit better. All right, and we'll go ahead and solder that. I'm going to put a little extra solder on this, and it's actually going to go down inside the wire and re-tin it. Yeah. And I moved it just a little too soon, so it started to pull out. So I'm going to melt it, push it back, let it stabilize, and then I'm going to go back and do the other one. Now on this case, because I went in here and I nipped off some of those wires, I have to be a little careful that these two aren't going to short on each other. So I'm coming back afterwards and making sure there are no little stray copper strands. Like I mentioned before, the better way would be to get a little tiny drill bit and just enlarge the hole. But I didn't think you might not, I thought you might not have that, so I wanted to show you another way. Alright, that looks good to me. Another thing that would be a really good idea in this situation, most people who make things have a hot glue gun at home. After you have verified that none of the wires are touching and that this is clear, just a little glob of hot glue there, or it could be silicone, but either way, that will both give support for the wire and prevent them from ever touching each other. That's what I would do if I was going to give this to somebody to use. Alright, so the first thing we want to do before we put the chips in is a quick power test. We'll put power in it, make sure nothing weird happens. Of course, I had this unplugged while I was soldering it. Alright, now we will put the chips in. Alright. So in goes the 555. We're keeping track of this notch. I'm putting in one side and then just kind of very gently with my fingernail seating the others from the other side. Taking a look at it before I push it down. You know, it still doesn't look quite right to let me pull it out. And I think if I straighten these just a little bit and push them in, and you can do that by laying it on its side a little bit like this, so that they even back up, and then just kind of look at it, make sure they still look even, make sure you've got the orientation right. And you don't want to push down until you're sure that all the pins are where they belong. This one side that's nearest to me is being a bit of a stinker with them going in, but it's in. So again, I'm going to prep this one, seeing how I've learned a little bit about how tight these sockets are, by bending them in just a little, again laying it on its side. And then going back and checking them. That they all look straight. Keep this notch in sight. Okay, and it's sitting on there more or less straight. I'm going to go ahead and push it all the way in. And it is seated. And I will post a link to this circuit, or so that, because we didn't get it here, but I think you probably want to learn a little bit about what one of these counters can do and how it works. There's a good one, I think, in the CMOS Cookbook, so I may use that as my reference. But basically the way it's going to work is this little timer is going to produce pulses, and those pulses are going to cause this counter to change pins as to which one is high and can run the LED, and it should just go around and around and around. So before I power it up, I want to get rid of these little bits of solder and other things because they could possibly short my circuit out. Always one last check, doesn't hurt. One last check that our wires look good. And I think we're ready to go. And this is the, as they say, the moment of truth. And there we go. They're chasing around. So what does this switch do? I guess it stops them on one. It's kind of like a game. Let's see. Well, that's really interesting. I don't see a difference with the switch in which state it's in. I had kind of assumed that when you press the switch, then they would go around and then it would stop on one. But this is a good test. It means that we're getting pulses out of our oh, there it goes. Okay, I spoke too soon. Well, that's really cool. They have put a sort of delay in there which extenuates out the pulses so that they get longer and longer. And that's probably why we have these two capacitors. One is for a regular pulse length and one is going to wear out and allow it to stop. All right, let me press this again just for a moment. And this time I won't touch it. I was just being impatient. Yeah, so if you've got a game or something that needs to choose between 1 to 10, this could be a fun thing. All right, so I hope you found this useful. If you've got any questions, let me know. If you want to leave a comment, please do so. And please subscribe, please like, and I'll see you in our next video.